Guys, hope all of us are doing fine. My name is Ernest, and I'd like to welcome each and every one of us to my channel of Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the second bit of the orbital diagrams and the electronic configuration. And of course, this is going to be particularly concerning the various rules that we're going to follow in trying to make these specific orbital diagrams. Now, in our last discussion, I mentioned that, of course, we're going to look at some of the concepts which we're going to come across. And of course, I mentioned the concept of energy levels, which we had discussed particularly in details. And then I mentioned the concept of sub-levels, which we had given specific designations. Now, I said, of course, we're going to designate this one using N, L, and of course, lastly, I talked about the concept of orbitals. Now, in order of arrangement, of course, I said that this is going to be leading to these specific sub-levels. And the sub-levels together are going to build up what we refer to as the energy levels. Now, in this case, I mentioned basically that the energy levels are going to be indicating the relative sizes of energies and the sizes of atomic orbitals. And of course, I've mentioned that these are going to range from the value of 1 to 7 given as such. Now, in this specific case, of course, I also mentioned that these specific sub-levels are going to be represented using the letter L. And of course, these are going to be given in terms of orbitals, which we had mentioned for S, P, D, and F, arranged in an increasing order of increasing energies given as such. And of course, I mentioned that basically these are going to be the S, P, D, and F orbitals given as such. Now, talking of the concept of orbitals, I basically mentioned that we're going to be using a representation of ML, just as we have mentioned for N, L, and ML given as such. And of course, these orbitals are going to be forming a various range of orientations in space, which are going to be containing these specific electrons. Now, I mentioned that the S orbitals, the S, of course, is going to, sub-level is going to consist of just a single orbital. And then I mentioned that the P sub-level is going to consist of 3 orbitals. And then, of course, subsequently, the D and F are going to consist of 5 and 7 orbitals given in that specific order. Now, today we are going to look at specific rules which are going to govern the arrangement of electrons in these orbitals. And of course, these are going to be giving us various orbital diagrams that we're going to come across perhaps using various examples. Now, in a summary form, of course, I've mentioned that we can give this a specific description of our first discussion in tabular form. And of course, that's going to give us a clue on how these particular rules are going to be applied in trying to construct orbital diagrams and electronic configuration. Now, suppose we had an energy level, of course, that specific point, and then we're going to have the sub-levels present in these specific energy levels, and then we shall have the number of orbitals are present in this specific sub-level, and then we're going to have perhaps the total number of orbitals irrespective of the sub-levels. Of course, I'm going to just elaborate on this, and then lastly, we're going to have the number of electrons, the total number of electrons in those specific orbitals given as such. Now, I said that if we have a first energy level given as such, we're going to have the sub-level present given as S, and this is going to consist of one orbital, and of course given as such. So the total number of orbitals basically therefore is going to be 1, and this is going to consist of a maximum of 2 electrons given as such. Now, for the second, of course, level, that's going to consist of S and P orbitals, which are 2 sub-levels, and then we're going to have this one giving us 1 electron for the S, and of course 3 electrons for the P orbitals given as such. And this, of course, are going to be a total of 4 orbitals, 3 for P and 1 for S. And of course, each orbital is going to consist of a maximum of 2 electrons. And that one in totality is going to give us a total of 8 electrons given as such. And then we shall have the third energy level, and this is going to consist of 3 orbitals, 3 of course sub-levels, S, P, and D given as such. And these, of course, are going to consist of 1 electron for S, three orbital, sorry for that, one orbital for S, 3 orbitals for P, and of course 5 orbitals for D given as such. And this is going to consist a total of 9 orbitals. And as we said, since each of the orbitals is going to consist of 2 electrons, and this is therefore going to give us a total of 18 electrons given as such. And then lastly, we shall have this fourth energy level, and this is going to consist of 4 orbitals given as sp, d, and f sublevels given as such. And these are going to be 1, 3, 5, and 7 for the total number of orbitals arranged in that specific order for the sublevels. And then we shall have 16 orbitals in total, which are going to consist of a maximum of 32 electrons given as such. Now, looking at this one, of course, this one is going to give us a specific sense of arrangement of electrons in these specific sublevels. And therefore, it's good for us to try and find out what are some of the rules which must be, of course, observed in trying to make, of course, this specific arrangement possible. Now, in this case, I'm going to mention 3 basic rules, and of course, which some of us have come across or discussed in our various videos. And of course, I'm going to mention them, therefore, in a summary form. Now, the first rule that we're going to observe in trying to make these orbital diagrams is the Aufbau's principle. Now, the Aufbau's principle basically concerns the electrons' occupation of the levels that we have mentioned. And of course, we're going to see that according to Aufbau's principles, electrons are going to occupy the lowest energy orbital that can receive it. So this therefore concerns electrons occupying the lowest energy level orbitals which can receive it, and then therefore that's going to be dictated according to the Aufbau's principle. Now, the next rule that we're going also to look at, perhaps in mentioning or a summary form, is the concept of the Hans rule. Now, the Hans rule, of course, just like the Aufbau's principle, also gives us order in which orbitals of energy levels are going to contain a specific number of electrons. And of course, we are going to see that orbitals of equal energies, of course, we're going to look at the concept of degeneracy. Orbitals of equal energies must each contain 1 electron before the electrons are going to be experiencing what we refer to as pairing up. Now, in this case, if we are going to represent our orbitals in terms of perhaps this small square diagram, let me use an example of the p orbitals, because they can just be given as a block. So we can have these p orbitals given as such. So there are going to be 3 orbitals, and suppose we give them in a 3 Cartesian coordinate system. This is going to be the x, y, and z. And of course, if this is the px, py, pz, the first orbital is going to have an electron which is going to be given as such, and then we shall have the next electron occupying, of course, the next degenerate or equal energy orbital given as such, and then we shall have another one occupying that one as such. Now, suppose we had 4 electrons which need to be filled up in this specific orbital. Now, these electrons have to be subsequently be filled in these 3 specific orbitals before we start performing what we call a pairing up, which is going to be 2 orbitals per 2 electrons per orbital given as such. Now, in this particular case, this is according to Hans rule, which says that orbitals of equal energy must each contain 1 electron before electrons are going to be paired up, as I have shown on the board. Now, the third rule which we are going to observe in trying to make these orbital diagrams and drawing of electronic configuration of various elements is Pauli's exclusion principle. And of course, we have mentioned also this one, as I said, of course, kindly be checking our links for this specific videos. And in this case, the Pauli's exclusion of principle is going to be, of course, dictating on the maximum number of electrons that are going to be having contained in these specific orbitals. And of course, it's going to emphasize on the specific orientation, or what we refer to as the spinning of these particular electrons. Now, as you can see from this px orbital, which I've just drawn this electron oriented in the upward direction. And of course, this other one, which was coming to fill up this particular orbitals, has been drawn downward. Now this is going to be referred to as what we call opposite spin. Now suppose I had an orbital like the s orbital, which is having electrons which are going to be arranged in this form. These are going to be in violation of Pauli's exclusion principle, and therefore this orbital need to be, of course, oriented in a way that is going to have an opposite spin given as such. Now that's going to be according to Pauli's principle, which says that if two electrons are going to be occupying the same orbital, just as I've given for this, they must be spinning in the opposite direction as I've indicated using these specific examples. Now in this case, these are going to be some of the basic rules which are going to assist us in trying to, or which we must follow for us to make appropriate orbital diagrams. And of course, as I've said, the energy levels are going to be represented using the N. And of course, they are going to determine from the periodic table, we had mentioned the concept of families, and of course, what we refer to as periods. Now, in this case, the energy levels, as I've said, are going to be represented using N, and they are going to dictate what we call the concept of rows in the periodic table. Now, this is going to create for us a link between what we have discussed and of its application in the periodic table. And of course, these are going to be also indicated for the sub-levels, which are going to give the various S, P, D, and F sub-levels. And this, of course, from the first discussion, which had given the rough sketch or a block of the periodic table concerning the concept of the S, P, D, and F block elements and their specific names which are mentioned. This, of course, are going to be the, alkaline and alkali earth metals, the transition elements, and of course, we are going to have for the D block elements, and then we're going to have this one for the metals and non-metals, and of course the noble elements, and then we are going to have for the inner transition elements given for F given as such. Now, also we're going to look at the concept of sub-levels perhaps in a specific discussion, which is going to be a subsequent or our next discussion from this specific one that we have had. Now, kindly check our description boxes for various links of other videos, and subscribe to our channel so that we can be having a healthy discussion on various concepts under the periodic table and periodic trend. So that is it for now, guys. Bye, God bless you. Catch us in our next video.